Okay, in the last video, we talked about the difference between an individual and a variable, and we looked at a nice, convenient list of players on the Los Angeles Lakers. And I think a lot of us would be able to answer the question, well, how do we get all of that data? And with a group of 15 players on an NBA roster, the answer is pretty simple. You ask them questions, or you ask their agent, or you measure their height. It's really not a complicated process to get all of the data for the Los Angeles Lakers or for all the athletes in the NBA. What about when we talk about the population? And let's start with the world population. Why not, right? There's approximately 7.5 billion people in the world. So if we were to go through, say, a roster of every single person in the world, just like we did for the Los Angeles Lakers, and study what their jersey number might be, what their salary is, what their college is, their height, their weight, that process would take forever. And to put things into perspective, um, let's narrow it down to just our country. Okay, in the U.S., well, let's start with the world population. Right, in the world population, again, we have approximately, we'll say, 7.5 billion people. Okay, now in our country, we have approximately 300 million. Let's say, just to be safe, we'll say 320 million people in the world, or I'm sorry, in the country. Okay. Even to work with a group that big, and again, to study just the variables of, now we don't play in the NBA, but we all have an income, or hopefully we do, right? So let's say we just want to study the variables of income, and we'll say height and weight, okay? Just those three variables alone. The process to gather that data from everybody in our country would take forever. Okay. In fact, we've deemed it necessary, or I shouldn't use the word necessary, but we've deemed it effective to do it once every 10 years. Okay. And that's with the U.S. Census. So the U.S. Census occurs once every 10 years. And we're going to give you some statistics about the census in just a minute, and why it's done once every 10 years. But basically, what the census does is, let me switch gears here a little bit. It's a way to accrue data and accumulate data on the people living in our country. So this was the last census done in 2010, and it's pretty basic in terms of some of the data, things that they're collecting: your first name, your last name, your ethnicity, okay, your race, whether you own the home or you rent the home, your telephone number, and you'll notice that one thing that jumps off the page for me is person two, person three. So this is given to every household, person four, person five, given to every household, and you have to account for every person in the household and fill it out. And this is done, again, once every 10 years. Now, even with the system as legitimate as the census, it's done by the Department of Commerce, so it's very legitimate and is well schemed out and orchestrated pretty well. There's still people that fall through the cracks. Okay, there are people that are homeless. There are people that are illegal immigrants. In fact, there's studies been shown that the census is biased towards people of higher income, and it kind of makes sense when you think about it. You're only pulling people who do have a household. Um, so it's truly almost impossible to account for every single person living on United States soil. But even for the 300 and in the last census, there were 310 million people accounted for. To collect that data for the 310 million people in our country, the census hired, I shouldn't say hired, but they used or utilized 1 million workers. Okay, so they utilized 1 million data collectors, we'll call them, all right, 1 million people to carry out this operation. Okay, they used 1 million people to fill out, to hand this form out, to accrue the data, to compile it, and then to report these numbers out. Okay, that is a huge number. Okay, and that's a huge number of people to use to try and collect this data. All right. If we look at this, right, for about 300 million people, we use 1 million. It's basically a 300 to 1 ratio. Okay, think of your line of work, your summer job. Okay, and you had to think of the ratio of customers to employees. Maybe it's around 300 to 1, but it's probably somewhere smaller. Um, if we took this ratio, right, and we wanted to apply this, okay, in other words, I need to figure out, based on this ratio that we use for the US, if by some chance I wanted to come up with a census for the entire world, what would that take? Okay. And again, how do we come up with that? Well, if you did 7.5 billion divided by 300 to do a census for the entire world, you're looking at, and a safe estimate would be 25 million workers, or 25 million people would need to do this. And again, this is only once every 10 years. 25 million people are needed to, we'll call it the data process. They're in charge of the data process for the world. 7.5 billion people. To put this 25 million into perspective, you would need every single person. We're not just talking about every adult. Every single person living in Pennsylvania, living in New Jersey, and living in New York City. Okay? Obviously, that's impossible to do. All right? So what's the point of all this? Why are we talking about a scenario that will never exist? Well, it's to show you the power and the usefulness, really the importance of what's called a sample. Okay, and rarely when we collect data in statistics do we have the opportunity to pull every single person in the population. Okay, however, once we accrue a number, whether it's a mean or percentage, from a sample, we use that to describe the population. Okay, so let's use our US 320 million as an example, and we want to try and figure out the number of people who go to college. All right, out of that 320 million. Okay, a statistic that I'm not sure of, and that's why we want to study it. So the question we want to answer again is how many U.S. citizens attend college. Okay, again, our population is 320 million. All right, in the U.S. Now, our sample, we select, we'll say 1,000 people. Okay, and some keywords when you pick a sample. Okay, you want that sample to be random. You want that sample to be representative. Of your population. Okay, so what I mean by that, there's there's 50 states in the country, and let's just say out of that 1,000 you had people from each state. Okay, that would be a little more representative of the 320 million. Now, if you really wanted to get into it, you could proportionally out of this 1,000, maybe there's an overwhelming percentage that are from Texas or from New York State, and not as many from Hawaii or a state like that, or Rhode Island. Okay, and you really think of the House of Representatives. Okay, that's a very representative sample of the population. Okay, so once we pick that 1,000, we have to ask ourselves: did we select the people randomly, and did we select the people representatively? Okay, and let's just say out of this 1,000, 100 people answered, yes, I attend college. Okay, so out of this sample of 1,000, 100 attend college. Okay, so that gives us a sample percentage or a sample proportion. We'll just say a sample percentage of 10%. Okay. Now, what statistics tells me I can do is I can take this number, even though it's only based off of 1,000 people. I can take this 10% and I can use that to answer the question of how many U.S. citizens attend college. As long as I preface it with it's based on a random representative sample of the population. Okay, that's the power of a sample. As we get further into the course, we'll talk about how we can make this number a little more accurate, something called a confidence interval, which also think of kind of hedging your bet to answer that question of, well, it's only based off of 1,000 people. How do I know it's representative of all 320 million? But we'll get to all of that in some lessons to follow. The important thing for us to just to recap, difference between a sample and a population. Obviously, the sample is smaller, population is much bigger, all right, and it's used to represent a population. Okay, the act of taking a sample and using data collected from that sample to describe a population is called inference. Okay, so inference is when we will say take data from a sample and use that to describe a population. Okay, that process is called inference. All right, if you had to think of a visual again for your population, if your textbook has a really nice visual, if this box is your population, your sample would be a little circle somewhere in that population. Okay, and we're using that circle to make a claim about the entire population.